Hello friends, welcome to engineering tutorial. So far in the material science and engineering section, we have covered the basic introductory concepts, the classification of engineering materials and the various properties that are analyzed for the selection of a material for a suitable application. In the previous video, we discussed about the basic mechanical properties with respect to stress, strain, and about the testing of materials. So in this video we are going to discuss about the stress strain behavior of the materials, the law that governs the stress strain behavior, and about the stress strain curve, okay, the basic concepts. So we also discussed this in the previous video. Just to have a quick look, stress and strain, the basic definition. Stress is the pressure which is applied per unit area on a material, the testing material, and because of the applied stress, the changes in the shape, the size, the dimension of the test material, it is called as strain. Okay, the mathematical representation of stress is force by cross sectional area. So sigma is equal to capital F by A, and for strain it is the change in length because of the applied stress divided by the original length, the initial length before stress was applied, delta L by L. The units for stress is Newton per meter square, or it is also Pascal is used, pounds per square inch is used. Strain is unitless because length by length it cancel each other out, but still sometimes meter per meter or inches per inches, these units are used. Now about deformation. This is very important from the point of view of the analysis of mechanical properties, because the stress strain curve, it basically is used for the analysis of the type of deformation the material will undergo when stress will be applied. Okay. So when stress is applied on the material, naturally it will undergo deformation. Now, if after the stress is removed, the material, the test material, it returns back to its original shape, size, original dimension, then it is called as elastic deformation. If the deformation is reversible and the original shape and size can be recovered, that is called as elastic deformation. If the process is irreversible, it means the change in dimension, the change in shape and size is permanent, then that deformation is called as plastic deformation. So when the material after undergoing deformation does not return back to its original form, that is called as plasticity. Okay, plasticity. And during this loading or the application of stress, the material, it shows two kinds of properties, elasticity and plasticity. Okay, the reversible one, that is called as elasticity, and the irreversible one, that is called as plasticity. Okay, so during loading and after, during the process of loading, it undergoes change in shape and size, the material, and when the stress is removed, returns back to its original state, then the material shows the property of elasticity. When it does not return back to its original form, then it is called as plasticity. So both these behaviors are analyzed and observed during the tensile test. Okay, it is very important. It is used for the analysis of tensile strength, the modulus of elasticity, ductility, hardness, toughness. So all of these properties are analyzed during the tensile test. Now it is carried out on the tensile test machine on a bar of uniform cross section. We discussed about the various types of tests that are performed in the previous video, and also about the various types of stress the material undergoes during application. So the tensile test machine looks something like this, the whole structure, and it consists of two jaws which hold the test piece, and these two jaws, they try to pull the test piece in opposite direction. Application of load is in this direction. In opposite direction, they try to pull the test piece. Now because of this, there will be an increase in length and a decrease in the cross sectional area. Okay. Now it is controlled. In older days, various mechanisms were used, such as hydraulic or pneumatic. Nowadays it is electrical systems are used, which can be controlled by the computer. So the test piece of uniform cross section, it undergoes expansion because of the tensile stress, and the stress strain relationship, it follows a particular pattern. Okay, a particular pattern, which is this, the stress strain curve. Strain in the x axis or the horizontal axis, stress in the vertical axis or the y axis. So it follows this curve, and these are the various important points for the analysis of the property of the material. Okay. So the various points M, N, P, Q, R, S, starting from the origin, they mean these things. The point M, it is called as the proportionality limit. N is the elasticity limit. P and Q, these are the upper and lower yield points. R is the ultimate strength, and S is the point of dislocation. In this video, we are going to discuss only the portion OMN, and the later these points we will discuss in a separate video, because it has a lot of associated things, and if I discuss them all together, it will be a little bit confusing. So we will discuss only from O to N. So M is the proportionality limit. Now as this term suggests, this portion OM, you can see that it is pretty much straightforward, a line passing straight through the origin. It means during this portion OM, the stress applied is directly proportional to the induced strain, the strain produced. So this portion obeys a particular law which is called as Hooke's law. Okay, the portion of the curve OM, it obeys Hooke's law, in which the stress applied is directly proportional to the strain produced. Stress is directly proportional to strain. That is, sigma is directly proportional to epsilon. Epsilon is the strain which is produced, or we can write it sigma is equal to C epsilon. So here C is the proportionality constant, which is called as the stiffness constant, modulus of elasticity, or Young's modulus. Okay, this constant C, the proportionality constant C, this is called as the stiffness constant, modulus of elasticity, or Young's modulus. Now within this range OM, the material is elastic. Now elastic means when stress is up to this point M, okay, if we draw a line perpendicular from M to here, this axis, then during this point the material will behave as elastic. It means that within this range, any stress applied, when that will be removed, the material will return back to its original dimension, original shape and size. The change will not be permanent. But beyond that, actually Mn is also within the elastic range, but still beyond N, any stress applied will cause permanent deformation. Okay, right now you just understand that. The other points we will discuss in a separate video. So within ON, the material will behave as elastic material. Okay. Now the portion Mn, that indicates the maximum stress the material can withstand and return back to its original dimension. But during this portion Mn, it will cause temporary deformation. It means that the material will not immediately return back to the original shape and size. It will take some time, but it will return back. But within OM, it will return back immediately. But within this range MN, it will take some time. So it will cause temporary deformation, and the material returns back to the original state after some time. So from O to M, when the stress is removed, material returns back to its original state immediately. From M to N, material returns back to its original state, but after some time, and it is called as temporary deformation. Okay, so within ON, it is the safe zone, you can say, for the material in terms of permanent or temporary deformation. Beyond N, it will the deformation will be permanent. So we have to analyze only from O to N, OMN portion. The remaining points P, Q, R and S will discuss in the next video. So this is the analysis of the stress strain behavior in terms of the stress strain curve, and we discussed the linear portion or the elastic region which obeys Hooke's law. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.